Spring 1943 in the dusty scrub hills of Tunisia. The sound of diesel engines fades. Shouting stops. A German recovery team finds itself standing before an American vehicle. A white motor company M3 Halftrack, captured intact after American lines had broken during a rapid German counteroffensive. The vehicle's paint is still wet in places where the sun hasn't yet baked it dry. Inside the cabin there is an open can of American coffee, the liquid congealed cold. A pack of Lucky Strike cigarettes sits on the dashboard, half empty. In the cargo bed, straps hang loose where American soldiers had moments before dismounted under fire. The vehicle idles, the engine ticking as it cools, to the German troops gathering around it, mechanics, engineers, officers. It represents something far more significant than a captured vehicle. It represents the beginning of an understanding that would reshape the trajectory of the war itself. This is not the story of one vehicle. This is the story of how opposing industrial systems encoded their entire approach to warfare into the physical structure of machines. It is the account of how a captured half-track, when examined closely by men trained in engineering and mechanics, became a revelation so complete that it would transform the ideology of those who witnessed it. The half-track was German officers' first practical lesson in why the war, despite victories in the field, had already been decided in the factories of the American Midwest months before the outcome would be determined on the battlefield. To understand what the Germans found, when they opened the hood of this captured American vehicle, one must first comprehend what they already knew about their own half-track design, the TKFZ 251, the German half-track that had become the standard armored personnel carrier for Wehrmacht Panzergrenadier units, represented the pinnacle of German mechanical thinking. It was a complex machine. The designers at Hanomag had created a vehicle of genuine sophistication. The armor was carefully welded in multiple angled plates, each one cut to precise dimensions and fitted with exacting tolerances. The track system employed an interlocked road wheel arrangement called the Schachterlaufwerk, a suspension system that distributed weight excellently across bogies, reducing ground pressure, providing superior traction across difficult terrain. The interleaved wheels with rubber pads dampened vibration. The system was an engineering marvel, and it was a nightmare to maintain. The complexity of this suspension design meant that when a single road wheel needed replacement, mechanics often had to remove multiple wheels just to access the damaged component. In the muddy conditions of the Eastern Front, particularly during spring thaws and autumn rains, mud and snow accumulated between the interlocked wheels, often freezing solid and immobilizing the vehicle entirely. The solution involved hours of labor, heating, careful extraction. The design that looked impressive on paper, engineering students were taught to admire it, became a burden in the field. The German factories that produced the ZKFZ and 251 were not assembly lines in the modern sense. They were workshops. Master craftsmen worked on each vehicle. Precision was paramount. Each armor plate was welded by hand. Each component had to be fitted with exacting care. The C-model variant, which saw large production runs, featured a complex array of angled armor plates, each one requiring careful calculation, cutting, positioning, welding. The production rate was not measured in hundreds per month or thousands. The Dresden workshops, working at capacity, produced something closer to dozens per week. Over the entire course of the war, with multiple manufacturers contributing, the Germans would produce 15,252 Syndicatvzaders, 241s in all variants. Everyone represented hours of skilled labor, precision work, artisanal production in an age when the enemy had already abandoned such methods. In May 1942, in the desert near Gazala, the Wehrmacht had captured its first intact American Jeep. The reaction among German engineers had been dismissive. The vehicle seemed crude. The engineering appeared simple. The Americans, it seemed, had taken a civilian truck platform and armed it without sophistication. The Jeep could not compare, the engineers concluded, to German design standards. But as captured vehicles accumulated, from North Africa, from occasional actions in Europe, from repair facilities where American prisoners were interrogated, the German assessment began to shift. The mechanical engineering officer, who would provide the most detailed analysis, was Hedman Friedrich Müller, a graduate of the Technical University of Munich, who had designed civilian automobiles for Opel before the war. His examination of captured American vehicles documented in reports that survived the war, marked a turning point in how German planners understood the competition they faced. Müller was not impressed by flashy design or theoretical efficiency. He was concerned with one question: how could American industry produce such quantities of vehicles that seemed, by German standards, nearly crude in their simplicity? The answer, when he examined a captured M3 Halftrack closely, became apparent immediately. The vehicle was designed not for perfection, but for replaceability. Every component that could be standardized was standardized. The bolts were metric, yes, but more importantly, they were uniform across models. The nuts matched. The washers were interchangeable. When a bolt from one Halftrack was removed and placed into another, it fit without adjustment. This was not incidental. This was systematic. The transmission was a White Motor Company design, a commercial transmission modified for military use. But instead of being unique to this vehicle model, it was shared across multiple American vehicle types. The engine, White 160AX 6-cylinder inline, was similarly standardized. Field manuals for the engine were identical whether the engine was installed in a Halftrack, a full truck, or another variant. Spare parts for the engine manufactured in Kansas fit seamlessly into engines manufactured in Detroit or Cleveland. The shock to German engineers was complete when they realized this was not an accident of design but a deliberate philosophy. American industry was organized around the principle that interchangeability was worth far more than perfection. The armor plating on the M3 Halftrack told its own story. The plates were not angled in complex geometric patterns. They were largely flat or gently sloped. They were bolted together rather than welded, meaning that damaged sections could be removed and replaced without requiring a full structural overhaul. The rivets were standard sizes. The welding, where it occurred, was done by machine rather than by hand. The entire structure could be built quickly by semi-skilled workers following simple procedures rather than by precision craftsmen, requiring years of training. The most profound revelation came when German technicians attempted to analyze the manufacturing process. They realized that every M3 Halftrack built was essentially identical to every other M3 Halftrack built. The variance between individual vehicles was minimal. When spare parts arrived at a repair facility, they could be installed into any Halftrack in the theater anywhere in the world. The American Army maintained unified part catalogs. A mechanic in the Pacific knew that a replacement transmission shipped from California would fit exactly into a Halftrack in North Africa. Identical training manuals, identical parts lists, identical procedures. The entire system was unified in a way that German military logistics, which had evolved through decades of independent manufacturers, each producing unique components, could never achieve. What Friedrich Müller documented in his analysis was something more significant than mere technical observations. He was observing two fundamentally opposed approaches to the problem of industrial warfare. The German system built for quality, precision, durability. Each vehicle was a carefully engineered product. The American system built for quantity, replicability, rapid production. The American approach seemed wasteful, sloppy, inferior in pure design terms. And yet, when Müller calculated production rates, the mathematics became devastating. The American White Motor Company, working with International Harvester and other manufacturers under a coordinated production program, had produced 40,000 M3 Halftrack variants by the end of production in 1943. 40,000. The German industry, with the Stichävs 251 as its primary Halftrack, had produced 15,252 total across all variants and all manufacturers over the same period, a 2.6 to 1 advantage in raw numbers. But Müller understood that the difference was not merely quantitative. The American vehicles could be maintained and repaired at a fraction of the time and cost required for German vehicles because of standardization. When an American Halftrack needed a repair, the part could come from a supply warehouse. When a German Halftrack needed repair, the part had to be manufactured to exact specifications, or the vehicle had to be sent to a repair facility that possessed the machinery to fabricate it. One account, from a captured German mechanic's report, survives in fragmentary form. It records a conversation between German technicians examining a captured Halftrack and an American prisoner they had temporarily released to assist with understanding the vehicle. The American, asked why Americans bothered with such seemingly crude design, responded, "We don't fix them. We replace them." There's always another one coming up the supply line. The German mechanics apparently sat in stunned silence when they understood what he meant. In the American system, a half-track that couldn't be quickly repaired in the field was not nursed back to health through careful machining and restoration. It was stripped for usable components and a replacement was requisitioned. Another vehicle would arrive within days. The presumption encoded into American military logistics was that vehicles were expendable. They were treated as consumable goods, not as precision machines to be carefully maintained indefinitely. This philosophy horrified German military planners, who had been trained to view every weapon system as a precious resource to be preserved. And yet, the American approach made perfect sense when one understood the underlying production capacity. If a nation could produce more vehicles in a month than it lost in combat, replacement was cheaper than repair. If parts were absolutely standardized, sending a replacement vehicle thousands of miles was no more complicated than shipping a spare part. The American industrial system had been organized quite deliberately around the assumption of abundance. The implications became even more stark when German engineers considered the production processes. The American factories employed assembly line manufacturing. The partially completed vehicles moved along production lines. Workers performed specific repetitive tasks. The same person attached the same component in the same way thousands of times. Skill came from efficiency and speed, not from precision craftsmanship. The assembly line approach allowed for rapid production by workers with minimal training. A factory that had been manufacturing civilian trucks could be converted to military half-track production with relatively little disruption. And multiple factories could be converted simultaneously, their output coordinated through standardized designs and centralized parts allocation. By contrast, German factories were organized around the workshop model. Each vehicle was largely constructed in place. Workers moved from task to task. The precision required meant that training took years. Converting a factory from one production task to another required careful planning and the preparation of specialized tooling. The disruption was significant, and adding new factories to a production program meant training new workforces from the beginning. The German system was inherently slow to expand production capacity. These differences would become apparent in the later stages of the war. In the desperate final years, as American production accelerated and German production contracted under bombing, the distance between the two systems widened catastrophically. At the peak of M3 half-track production in 1942-1943, American factories were producing more than 30 vehicles per day across all manufacturers. German factories working at maximum capacity could produce perhaps one or two CDK-Kevzo, 251s per day in aggregate. The mathematics were not close, and yet the true significance went beyond the numbers. The standardization philosophy encoded in the American half-track was part of a larger system. When hundreds of thousands of American half-tracks were produced, each one identical, the military supply system could be simplified in ways that German logistics could never match. American transport vehicles could carry identical spare parts destined for multiple different vehicle types. German transport vehicles had to carry different spare parts for different vehicles, meaning lower efficiency and higher volume requirements. American mechanics could be trained once and deployed anywhere. German mechanics had to be trained specifically for each vehicle type they would maintain. What emerged from the careful study of captured American vehicles, documented in multiple German technical intelligence reports during 1942 and 1943, was a recognition of something deeply troubling. The German army had superior tactics and superior armor design. The Sherman tank, which German engineers also examined, was lighter, less well-armed and less heavily protected than contemporary German tanks like the Panther and Tiger. But the Sherman was produced in vast quantities, shipped to all theaters, replaced when damaged, and maintained by mechanics who could keep machines running with minimal specialized training. The German tanks, by contrast, were precision machines that required expert maintenance and could be kept in combat only through elaborate support structures. One German officer, writing after the war, recalled the moment of realization. We had believed we were fighting a nation of shopkeepers, people too soft and too commercially minded to build weapons that could match German engineering. We had believed this about their tactics as well. We thought American commanders were amateurs. We thought American soldiers would break under our assault. What we did not understand was that American strength was not concentrated in any single weapon or any single man. It was distributed. It was systemic. It was in their belief that nothing was sacred, that everything could be replaced, that you didn't make things last. You made things in overwhelming quantity. This philosophy, which we dismissed as wasteful, turned out to be more effective than our philosophy of quality and precision. The captured Halftrack served as the physical embodiment of this realization. German officers could examine it, measure its components, understand its design, and in understanding its design, they could begin to understand why Germany had already lost the war, not in battle, not yet, but in the competition for industrial production. The war would continue for 2 more years. Germany would fight with brilliance and desperation. But the outcome had already been decided in factories that the German High Command had not fully appreciated. By 1943, German planners were becoming aware of American production capacity through intelligence reports. Intelligence officers had compiled statistics on American factory output. The reports showed production rates that seemed impossible. The Willow Run plant near Detroit, a Ford facility, was producing B-24 Liberator bombers at a rate that exceeded Germany's entire monthly aircraft production. Each bombers took more than a year to design and engineer, yet American factories were producing them at rates that would have required years from German factories if the task had been assigned. The Liberty shipyards were launching merchant vessels faster than German U-boats could sink them. And the vehicle production, half-tracks, trucks, tanks, was occurring at scales that Germany could not conceptually grasp from its experience of manufacturing. The technical documentation that emerged from the half-track analysis circulated through German military headquarters. These reports, which would survive the war and eventually be discovered in archives, painted a picture of industrial capability that fundamentally exceeded what German theory believed was possible. The chief of German Army procurement attempted to increase production rates. The Military Economic Planning Office developed strategies to maximize output, but the fundamental problem could not be overcome quickly. The German industrial system, for all its sophistication and engineering expertise, was not designed for the kind of mass production that the American system had achieved. The structure of German industry reflected German assumptions about how the war would be fought. It would be short. Germany would win decisive victories through superior tactics and leadership. The armies would be equipped with weapons of superior quality that would overcome any numerical disadvantage through performance. The Germans had not planned for a long war of attrition where the nation with the highest production capacity would ultimately prevail. The American system, by contrast, reflected a very different assumption. The Americans planned for a long war. They designed their production systems to ramp up rapidly. They standardized everything so that production could be distributed across multiple factories. They built with the assumption that losses would be high and replacement would be continuous. In retrospect, the captured half-track in Tunisia in 1943 was a symbol more than a vehicle. It symbolized the fact that the Wehrmacht had already encountered the weapon it could not defeat. Not any particular tank or aircraft, but the entire organizational structure and philosophical approach that allowed American industry to produce weapons faster than Germany could destroy them. Tactical victory was still possible. The Wehrmacht would continue to achieve tactical victories in combat for years. But strategic victory, the competition for industrial output that would ultimately determine the war's outcome, was already lost. The standardization of the American half-track extended to training and doctrine as well. Every American half-track driver followed the same training curriculum. Every American half-track mechanic learned the same maintenance procedures. Every American half-track commander understood the same operating principles. The training could be standardized and delivered to hundreds of thousands of soldiers with confidence that they would all understand their vehicles and each other's vehicles. German training, by necessity, had to account for multiple different vehicle types, each requiring specialized knowledge. A half-track commander trained on the SID KFZ. 251 would not automatically know how to operate a SID KFZ. 250 or the various specialized variants. The interoperability that American standardization achieved was simply not possible in the German system. What happened to the captured half-track in Tunisia is not entirely documented. Some accounts suggest it was kept for further study, Some suggest it was hastily refurbished and pressed into German service, marked with Wehrmacht insignia, used alongside German vehicles. If this occurred, it would have created an additional complications for the German logistics system. Now German supply officers would have to maintain inventory, not just for various German vehicles but also for captured American vehicles that appeared in small numbers throughout their unit organizations. The Americans, meanwhile, faced no such complication. All their vehicles were identical. The supply system was unified. By May 1943, when the Axis forces in North Africa surrendered, approximately 250,000 German soldiers became prisoners of war. Many of them were transported to prisoner camps in the United States. And there, in those camps, they would encounter not just the half-track or the Jeep in isolation, but the entire American system functioning at scale. They saw weapons in abundance. They saw vehicles being casually discarded when they could no longer be quickly repaired. They saw the sheer volume of production that American factories were achieving, and many of the German prisoners, when they later returned to a defeated Germany and began rebuilding their nation, carried with them a lived understanding of what industrial capacity meant. They had not merely been defeated in battle. They had been overwhelmed by industrial production. They had been made to understand through direct observation that a system based on standardization and replaceability could produce more than a system based on precision and craftsmanship when total war required total production. The German officer corps, even those who never personally examined the captured half-track, began to understand the same truth through technical reports and through the mounting evidence of American production capacity. Some attempted to shift German production toward the American model. The AOSFD model of the SDKFZ 251, introduced in 1943, represented an attempt to simplify production by reducing the number of angled armor plates and making the design less complex. But this change came too late to alter the fundamental balance. The new model was still more complex than the American vehicle. The production rate still could not match American capacity. The philosophy of the German system was too deeply embedded to change rapidly. The meaning of the captured half-track was simple and devastating when finally understood. Germany had entered the war with superior tactics, superior leadership, and military innovations that gave it local advantages, but it had failed to recognize that modern industrial war could not be won by tactical brilliance alone. The nation that could organize its industry to produce the greatest quantity of weapons, that could standardize designs to maximize efficiency, that could replace losses rapidly rather than carefully preserve each weapon, that nation would ultimately prevail. The Halftrack, when German engineers examined it and understood the philosophy it embodied, was the vehicle in which this truth was carried. It was crude by German standards. It was simple. It was designed to be mass-produced and replaced rather than carefully maintained. And precisely because of these qualities, it represented a system far more powerful than the German system it faced. The technical intelligence reports that emerged from the examination of captured American half-tracks, Jeeps, trucks, and tanks in 1942 and 1943 filtered up through the German military hierarchy. They reached the armaments ministry. They reached the high command. They were read by officers planning strategies, and they conveyed a consistent message. The war cannot be won through superior individual vehicles or weapons. The war will be won by the side with superior production capacity. And American production capacity was vastly, perhaps insurmountably superior to German production capacity. The numbers did not lie. The mathematics were undeniable. And as the war continued, and as production rates were documented month after month, the truth became inescapable. What might have been changed if Germany had encountered this truth earlier? Historians can debate this question. Perhaps the entire German approach to manufacturing would have needed to be restructured from the beginning of rearmament in the 1930s. Perhaps Germany would have needed to adopt mass production and standardization earlier, but by 1942 and 1943, when the captured vehicles were being examined, it was too late to fundamentally restructure the German industrial system. Germany was already fully mobilized for war. The factories were already producing at maximum capacity with existing designs and processes. Conversion to a new system would have caused disruption without offering guaranteed improvements within the time frame required. And so the captured Halftrack stood as a monument to a realization that came too late. It represented a system that Germany could understand, but could not replicate quickly enough to matter. The American approach to vehicle production, reflected in the simple, standardized, readily replaceable M3 Halftrack, embodied a philosophical approach to industrial warfare that Germany had not anticipated and could not match. The vehicle itself was less impressive than German vehicles in isolation, but as part of a comprehensive system of standardization, mass production, and rapid replacement, it was part of a machine so vast and powerful that no individual weapon system could overcome it. The final paragraph of one German technical analysis, written by officers who had examined captured American vehicles, captured the essence of the realization. The Americans have not won the war through superior individual weapons. They have won it through superior organization. Every component of their vehicles is standardized. Every factory knows exactly what to produce. Every mechanic can repair any vehicle. Every replacement is available on schedule. They have turned military production into mass production, and they have done this at a scale we cannot match. The war will be won not in the next battle or the next campaign, but in the factories, and their factories have already won. The captured Halftrack in Tunisia was eventually abandoned, destroyed, or lost to history, but the truth it had revealed lived on, carried by German officers and soldiers who understood what it meant. They understood that they had been fighting not just against an enemy army, but against an industrial system so comprehensive and so powerful that it could produce weapons faster than they could be destroyed. They understood that standardization, which seemed crude and inferior to precision manufacturing, was actually more powerful when applied at industrial scale. They understood that the philosophy of replaceability, the American willingness to discard a vehicle that could not be quickly repaired and requisition another one, represented a level of confidence in production capacity that Germany could never achieve. This understanding would reshape German thinking after the war. In the reconstruction of Germany, German engineers and planners would study American production methods. They would learn the lessons that the captured Halftrack had taught during the war, and in rebuilding German industry, they would adopt standardization and mass production techniques that American industry had pioneered. The Mercedes-Benz Company, Volkswagen, Bosch, all of these companies would study American production techniques and attempt to apply them to their own manufacturing. The lessons written into the design of the M3 Halftrack, lessons that German officers had learned bitterly during the war, would become the foundation of West German industrial success in the post-war period. In the end, the captured Halftrack was a teacher. It taught a lesson that could not be unlearned. It showed that in modern warfare, the nation with the most sophisticated individual weapons would lose to the nation with the most sophisticated production system. The Halftrack was crude, simple, designed to be mass-produced by semi-skilled workers, but it was precisely these qualities that made it superior in the competition of total industrial warfare. German officers who examined it in 1943 and understood its implications were witnessing the moment when Germany had already been defeated, not yet on the battlefield, not yet in the surrender, but in the silent, inexorable fact that the American system could produce more than the German system could destroy. The war would rage for 2 more years. Millions more would die. But the outcome was already determined. The moment a German engineer opened the hood of a captured American Halftrack and realized that he was looking at a vehicle that embodied a manufacturing philosophy so fundamentally different from his own that the war, in essence, was already over. The Halftrack stood as the symbol of this truth, that in the age of industrial warfare, ideology and culture and individual brilliance mattered less than the boring, bureaucratic, systematic processes through which a nation organized its factories and its supply chains. Germany had lost not because its soldiers were less brave, or its officers less skilled, or its individual weapons less capable. Germany had lost because it entered a war against a nation whose industrial system was designed to produce weapons faster than they could be used up. Every captured American vehicle examined and documented and reported upon confirmed this truth. And every German officer who understood what these vehicles meant carried that understanding forward into a future that would be shaped by the lessons written into the design of the American M3 Halftrack. Lessons about the decisive importance of standardization, mass production, and the philosophy of industrial replaceability in the warfare of the 20th century and beyond.